Gonna do some more Verilog problems. We'll try to do this, or 45 minutes, whatever first. Probably like 2 or 3 problems because these questions are a bit harder, especially these like counter ones because like you need to weave a bunch of modules together. But yeah, Happy New Year, everyone. Hope your New Year brings you a lot of money and so you can be rich and not have to work again, so you can spend all your time insulting your family members like they do in Succession. All right, let's go. Boom, 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 boom. LFSR, linear feedback register. Usually a few XOR gates produce next state of shift register. Akalo. LFSR is a particular arrangement where bit positions with a tap. Okay. With taps at 5 and 3. Taps at 5 and 3. All right. But one of the XOR gate inputs is no, I drew an XOR gate at position 5 for consistency. But one of the XOR gate's inputs is 0. So I guess it's just like a shift register with, okay, I guess that's what they said. So, what is the reset situation here? The reset should set the LFSR to 1. I'll just assume synchronous reset. So the top bit will be but if Q0 and you're XORing 0, isn't that just Q0? So why does it matter? You know what I'm saying? Seems like, so Q4 will feed in Q0, and then 1 gets 2, 2 gets 3, 3 gets 4. So it's kind of like this kind of a situation, except for number 3. I mean, except for 2. Yeah, no, it's for... And then Q0 goes to 4, and then 4 goes to 3, and then 3 XOR'd with 0 goes to 2, and then you have Q2, 1, 2 and 1. I just omit this one, right? Because anything XOR with 0 is just going to be the thing. So this, I think, just means Q0 being passed with, yeah. Okay, so this is just like um, just build the circuit, and except they scramble the names around. So why don't I just unscramble the names around? Yeah. And then assign artist as W, and then what is key? So logic clock. And then assign L is key 1. Connect the Q outputs to the red lights leader. So I'm guessing Q0 is just, this is just Q. All right. This is easier. So now I've kind of transformed the namespace to RQ and clock. And also I need L. R, L, Q, and RL, RQ, RL, RL clock Q, RL clock Q. Okay. Is there a reset situation? No, there's no reset. So always a positive clock. Q is just gonna be let's try to do it like this. A little easier. So L chooses between Q2 and R0. So if L, then R0. And then Q1 is choosing, again, L. So Q0 and R1. And then this is saying, if not L, actually Q2X or Q1. And then we have R2, if it's L, and that should be it for that one. Let's see. Oh, this passed already. So all the taps are XORed with Q0 is what they mean to say. So 5 is 0. Here it's okay, so 32's tap is, if it's like this, it's 0. So the base case is like let's just do this. First and foremost, it's a right shift rotator, so and then now I will overwrite certain bits. So if the tap so 2 normally would have 3, but Q2, so let's say I have a tap at position 3 or position I, then position I minus 1 is going to be position I XORed with position 0. So this tap at 3 affects 2, right? So this 22 should affect 21. So without the tap, it's just this, right? 0 back to 1, 21, 22. And okay. So that's done. This is done. Implement the following circuit. Okay, this seems a lot easier than pretty much all the other questions so far. I don't know why they gave it to me in this order. I don't know if this is synchronous. Okay, this is synchronous. Then that. Okay, so reset all these to zeros based on this negative reset, else.
Which one? Alice or Alice Tom? Which one? Alice or Alice Tom?
What's going on? Alright. I guess if I talk loudly, my phone will think I'm calling it. That's annoying. 0, 1, 2. So the out will just, this is 0, 1, 2, and so the out would get, 2, and then this 0 would get an in. Where's W? Oh, here. N equals 4. Okay, cool. Zero is the output, so I think 0 will be this for me, and then this will, so I'll just reverse it. So my Q0 and then Q3 is here. So it's just a reverse mapping. So then the leader would think that, so the leader will have Q0 as this guy. R is also swapped. Okay, that's great. So let me swap R as well. Any other tricky dick? No. So what do these have as inputs? These have as inputs this is not really an input because it feeds back into itself. So it has like a W as an input and a W, an E, and an L for the two selects, and an R. Right, W, E, L, and R as an input. And E chooses between Q and W. Oh, this also has a clock, obviously. If it's E, right, then we choose W. If it's not E, then we choose Q. Well, I guess now I got it wrong. So if it's not L, we choose as mux1, otherwise we choose R. And then this is our D. Which is mux2. So then output's just Q. So E and L have no transformations. And R should correspond. Because I reversed it. And then Q is just Q, which would get mapped to the leader. I guess, to be honest, this swap is kind of unnecessary because, oh, I don't know, actually. Okay, well, what's W? Oh, this is incorrect, so let's maybe solve this one first. Um, so this is all ones, which means this will pass. And we would just do this, right? Oh. Wait, no. 0, 1, 2, 3 out is Q of 3. Okay. I'm surprised that maybe there was some what? Oh, actually. Right? Q2 goes to Q3, yeah. Oh, surprisingly, the harder one was a one shot, and then the easier one took 2 tries. Let's all this then. You design a circuit for 8x1 memory. Writing the memory is accomplished by shifting in bits and reading as random access. You then use this circuit to realize a 3 input logic function. Okay. So Z is just a selector. Or sorry, ABC is just a selector for Q. The shift register input is S, which feeds the input of MSB is shifted in first. I don't get it. Q0 is the LSB, and if it's the input, yeah, this sentence is, what the hell is this sentence? So we have an input S which feeds the input of Q0. But if Q0 is the input, then the LSB is shifted in. Unless they mean the MSB is shifted out. But if MSB is shifted in first, then I don't get unless it's like a rotating right buffer and oh, I guess that makes sense. It's a rotating right buffer. So for example, if you wanted to write entries 1, 3, and 7, you would clock and then enable an S to write, clock enable S write, clock twice, and then for every double clock, you would enable once on the rotating right shifter, and then you do ABC as your read access. So is what I assume the raw case is, right? So this says I'm shifting. Yeah, I guess I really don't get this. This is like I might do a couple shift registers contain S, which feeds the input of Q0. I don't think it's rotating actually. I think this is just a typo. So if MSB shifted out first and Q0 is like your input and Q7 is your out, then you're shifting in S and Q of 6 to 0. So every time you enable Q of 7 gets popped, and every time you enable you can write a new memory in. Yeah, this makes more sense. I think. I really don't know what this means. So I think I'll look at the waveform running it and then work backwards to deduce the English in this problem. All right, so let's pretend this is the LUT, and then let's just look up the memory. So C is the select, Q of index. Yeah. Oh, okay, so I guess I did. Apparently you can show solutions. Oh, I guess, okay, you could do it like this, which is pretty cool. This is exactly what I did. Yeah, I guess it's the same. I guess the only thing is I made this more explicit. Cool. So refresh here. I don't know what cellular automata is, so I feel like this could be a bit hardy. If this is a bit hard, I'll probably just do one of these first ones, and then work on these longer ones tomorrow if that's the case. Is a one-dimensional cellular automaton with interesting properties. Okay. So that's the first part. We load some data, and so if these are zeros, I can shift left and shift right. So suppose Q of I, this says, this drags it by left. So like if index 1, then this is looking at index 0. So this is like I minus 1. Conversely, this is like I plus 1, because it pulls in the top bits to the lower. So Q of I is the XOR of Q of I minus 1 XOR with Q of I plus 1, which is what we want. It says that each clock success. Why is this Turing complete? I don't know why this is turned complete. Um, so it's zeros if it's all ones, all zeros are 1 0 0. Okay. Else 1. So and then I'll just say left is just um okay. And then also begin end, and then if load, then Q is data. I want to just determine basically like this, but like, you know, that. So 0 to 511, and then so next Q of I is just gonna be and Q is center, right? So if left it's just shorthand saying it's equal to 0, and or it's so like this, then I could also just take this whole thing and tilde it, but maybe a little easier to read like this. And then, right. So if all ones, all zeros, or this, it's 0, else 1. So this should evolve it to the next state for the center, and these are both 0 off, so the shifts should shift in the off stuff. Load does this, and then otherwise we evolve the automata like that. I don't know why it's turned complete, meaning one can simulate the other and the other can simulate it. Okay, so it's all F's. So Q starts at 1, meaning this is 0, and this is this. So, oh, I see. Well, I'll keep the parentheses, but what I'm missing is actually... Maybe I'll just do it like this. I wonder if the motif, like, it allows me to reuse the same in a for loop. It's quite interesting to see what happens. Okay, there are no mismatches. Is there a solution again? No. Well, okay, that's cool. That's it. Solved 110 problems, and this is rule 110, so that's quite sort of funny. And they probably did this on purpose. Happy New Year, and bye-bye.